analysis. Here is your chapter 1. Holy crap, I got a lot of emails. Your chapter 1, lesson 5 notes. So today we're going to talk about compositions of functions. So I started with kind of reaching back to you, back to geometry and back to thinking about transformations in compositions with geometry, and that notation was like all about rotating and revolving and translating, so sliding, right, or reflecting. We had a lot of that stuff. When we were looking at those in geometry, this notation here, this circle meant to do this side first, then we do this side, okay? And so those were your compositions of transformations in geometry. Whenever you saw that, the whole hint, right? The whole trick was make sure you're doing what's on the right hand side first. So these are what we read left to right, right to left. This is more like a slightly different approach here. And so the way that we read these is the same for compositions of our functions. So if we are plugging in a value into two functions and we're going through the first function's rule that it gives us, we get an output. Now what you do is use that output as your input for the following function and do it that way. And the end result is the end of our composition, okay? And the reason is this says f of g of x. So it's saying g of x goes first, then do f of x. Okay, that's because of the wording, what this actually says. Now, both of these are the types of notation you might see. They read exactly the same way. F of g of x. This one feels a lot more like literal, right? But this really does say the same. It doesn't say fog. That's how I always thought about it in 10th grade, right? It's f of g of x. So g of x goes first. So do this one first. Then whatever the answer to that is, it goes into f. Okay? So let's do some practice together. Let's do some practice together, right? And I've got the answers on the next page so that you have those, you'll see those answers. But do I have the answers to the polynomials? I do. Wow. I gave you guys the answers for all this. I'm so nice. Hope I'm hearing all these. Thank you, Mrs. Collins, that you're saying from home. All right. Here's my f function. Here's my g function. And here we go. This goes first. G of 4. So let's do g of 4 and do the substitution in. So that would be 4 squared. Cool. Well, I know what that is. That's 16. So g of 4 equals 16. Now, what that means is this is now the input for the f function. So now I've done the g function. I got my answer. Now that becomes the input into the f function. This will be 2 times 16 plus 3. And while I can very easily do this in my head, I just want you to get used to seeing me use this nice little emulator over here, right? 2 times 16 plus 3 is 35. So the answer to this, f of g of 4 is 35. There you go. Okay. Let's do it again. And this, the notation is different, but it's saying the same thing. Plug this into the g function first. So here we go. G of negative 2. So g of negative 2 means to replace x with negative 2. Well, remember, that's in parentheses, so it's negative 2 times negative 2. And negative 2 times negative 2 is, of course, positive 4. So now what that means is positive 4 is the input into the f function. All right, so it's 2 times 4 plus 3. There we go. 2 times 4 is 8. 8 plus 3 is 11, right? So f of 4 equals 11. But what I'm going to write for my final answer, f of g of negative 2 equals 11, because that was the notation I was asked in. So that's the notation I chose to write my answer in. I'm just kind of, I was copying what I was asked to do, keeping it simple, right? Oh, g of f of 4, right? So f of 4 goes first. 2 times 4 plus 3. Hey, we just did that. That was 11. So now what that means is 11 is the input in my g function. So g of 11 is 11 squared, right? Which happens to be 121. So that means that g of f of 4 is equal to 121. Okay? Hey, look. Those answers and then that notation being used right here. Showed all that same work. You got this. All right. Easy enough. But we're in Algebra 2. So what's the catch? The catch is you might not have an integer that you're being asked to plug in. You might be asked to plug in a polynomial. Well, this polynomial is the entire thing that will replace your variable. So here is where we're going to have to kind of remind ourselves how to FOIL and things like that. Like we'll have to do some distributing, some FOIL, depending on what your functions look like. Well, we're using the same two functions we used on the front, right, purposefully, right? I'm already using these functions. This time, instead of plugging in an integer with g, I'm plugging in 2x. So it's going to be g of 2x equals 2x in parentheses squared. That whole thing is squared. Well, what's 2 squared? It's 4. What's x times x? It's x squared. So now this is what came out. And since this is what came out, that's what now subs in to the f function. So what we're replacing x with in the f function is going to be f, 4x squared. That's what we're replacing x with in the f function. So it'll be 2 times 4x squared plus 3. Okay, really the only thing that ends up changing in this particular one, in this instance, 2 times 4 is 8x squared plus 3. So I'll just write my initial notation. F of g of 2x equals 8x squared plus 3. If you're plugging in a polynomial as your input, you're likely getting a polynomial as your output. You know, it's possible that the polynomial pieces cancel out and you get an integer, but it's unlikely. It's far more likely that you'll get a polynomial answer for that once that's the case. Okay. G of x minus 2. Okay, that's the start, right? So g of x minus 2, that means that what you're plugging in here is x minus 2, and you're squaring it. Well, when you see a polynomial squared, automatically rewrite it back out as x minus 2 times x minus 2, the polynomial times itself, the binomial times itself. Because when you see it in this form, you remember that you're supposed to be FOILing. You remember that you're supposed to be FOILing. So this is first outer, inner last. You get x squared minus 2x minus 2x plus 4. Negative times negative equals the positive 4 at the end. And combine like terms in the middle. Now, the crazy part about this whole thing now gets plugged in to your f function for your variable. So whatever you yield, that's now what gets plugged in for x. So 2 times x squared minus 4x plus 4 plus 3 at the end. Okay? So distribute that too. 2x squared minus 8x plus 8 plus 3, like terms at the end. 2x squared minus 8x plus 11. And this would be f of g of x minus 2. Oops, I cut off my 11. My bad. There you go. I caught him at the end. All right. Okay, one more. Plugging in x plus 4. This nice box says the things I've already reminded you of. F of x plus 4 equals 2 times x plus 4 plus 3. Cool. So I distribute the 2. And now I combine like terms. And this guy goes in for the g function. So g of 2x plus 11 equals 2x plus 11 squared. So I'm writing a binomial squared. So that means, again, I need to write it out as the binomial times itself. So I remember that this is a FOIL. And I FOIL. 2x times 2x is 4x squared. 2x times 11 is plus 22x. And that happens again in the middle here. And then the end, 11 times 11 is 121. Combine like terms in the middle, I get 4x squared plus 44x plus 121 as my final polynomial. Let me just scooch that guy up and get my notation down here. G of f of x plus 4 is what I plugged in. Oh, I tried to do it again. Tried to cut off my end. There you go. The beauty of a video is that you can pause, rewind, go back, look at that again. Okay? So if you need to, plus in your note packets, you already have the answers to all of those things where I showed the work too. So they're already there for you if you need them. Not too shabby, right? It's almost like I was thinking about you. Okay, homework on this guy. Come see me for office hours if you need me. If you want to do any of them together, you're welcome to. Just sign up and I shall be here. All right? I'll be seeing you guys. Have fun with your compositions of functions.